Hello students, in this video we will continue with the third chapter playing with numbers solution exercise 3.5. First question of exercise 5 says that here are two different factor trees for 60 and you have to fill the missing numbers. So you have to just fill the factors of 60 like this. The 60's factor is 6 and 10. Then 6 is further divided into 2 and what will be the another number for this? It will be 3. Right? For 10, it will be 2. So just have to fill it like this. Very simple. This is 60. 30 into 2 will be the factor. Okay. And then 30 factors are 10 and 3. Then 10 factors you can write 5 and 2. Okay. So this is how you will fill it with 9 factors. Which factors are not in the prime factorization of a composite number? So answer 2 will be, you have to tell me which of the factors, which factors are not included in the prime factorization. When we do the prime factorization of any of a composite number, which of the factor will not be included? 1. 1 is not included because it is not the prime. 1 is not included in the prime factorization because it is not prime number. And with this, the factor itself is also not included. The number itself, sorry. The number itself is also not included because it is also not prime number. Okay. So these are the two factors. Then answer 3. Question 3 is saying, write the greatest 4-digit number and express it in terms of its prime factors. So greatest 4-digit number is greatest 4-digit number is 9999. Now you can do it by the factor tree method or you can do it by the prime factorization method, any. Let me do it with the prime factorization method. 9999, if we do it by the prime factorization method, it will give us 3 3s are 9, 3, 3, 3, then 3, 1, 1, 1, 1. Then 1, 1, 1, 1 will be go with the 11. 11 ones are 11, 11 ones are, sorry, 0 and 1. Again, it will go with 101 is the prime number itself. So the 999 prime factors are 3 into 3 into 11 into, okay, let me write here 101 also. 101. Or you can do it by the factor tree method, in which you will make it like 9999 and then divide it into different parts like 9 and 1111. Then again divide it into 3 and 3 and then 11 and 101. Okay. Any of the method will be fine. Then coming to the next question, answer number 4 is saying, write the smallest 5-digit number and express. The smallest 5-digit number is 1000. That is 10,000. Let me do it with the factor tree method. So I will just make factor tree like, you can do it by prime factorization same or the factor tree method. Let me do it with the prime factorization only. 10,000, it will go by 2, then 5,000, then again 2, 2,500, then again 2. Okay. Because we have done it with the prime factorization above, the ladder method, let us do it with the that method, which is the factor tree method. 10,000, we can write it as in factor tree by the factors of 10,000. You can write as 4 and 2,500. Then 4 you can write 2 and 2. So these are the two prime factors that we got. Then for the 2500, we can write 500. Not 500 and 500. Let's just write 125. Then 25 is 5 and 5. Again, two prime factors we got. Then for 100, we can write 20 and 5. This is the prime factor. Then this 4 and 5. And this 2 and 2. So we can write 10,000 as 2 into 2 into 2 into 2 into 5 into 5 into 5 into 5. This is the prime factorization of smallest 5-digit number. Coming to the another, find all the prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime numbers. Let's do it by the method of ladder method. 1729, it will go by 9 and 2, 11 and 1. 7 first, so it will be 247. Then by 13, which is 19, and then by 19, which is 1. So prime factors of 1729 are 7, 13, and 19. Okay. We can see that 13 minus and you have to arrange them in ascending order. We have done it already. Now state the relation, if any, between two consecutive prime factors. So we can see 13 minus 6, 7 is 6, and also 19 minus 13 is 6. So that means difference is coming out to be 6. This is the relation. Difference between consecutive prime factors. This is only coming for the 1729. It will not always. 1729 is 6. This is the relation. Coming to the answer 6, the product of three consecutive numbers is always divisible by 6. Verify the statement with the help of some example. Okay. So, product of three consecutive numbers. Let's take a product of three consecutive numbers. Any three consecutive numbers we can take. It can be 2 into 3 into 4. Yes, which is equals to 6. No, sorry. Which is equals to 24, and it is divisible by 6. Right? If we write any other, we can write as 5 into 6 into 7, which is 210, is divisible by 6. Also. Okay. Coming to answer number 7. The sum of two consecutive odd numbers is divisible by 4. Now again, do it like this. In this, you have to do the sum. Two consecutive odd numbers. Now it is asking for two consecutive odd numbers. So let us write two consecutive odd numbers as 3 plus 5, which is 8, is divisible by 4. Let's take any other. We can give many examples if we have 13 plus 15, which is also 28, is divisible by 4. Then we can have any other also. Consecutive odd, 7 plus 9, which is 16, is divisible by 4. So you can give many others. Okay. Coming to answer 8. In which of the following expression prime factorization has been done? So if I see the A part, in this, it is not prime factorization because 4 is here, so no. If I see B part, 7 into 2 into 2 into 2. First of all, check the product as well, bache. 7 into 2 into 2 into 2 is giving us 56, and all are the prime factors. So it is Then 2 into 5 into 7, all are the prime factors. That means it is also the prime factorization. And if we see 2 into 3 into 9 in this, 9 is not the prime factor, so it is not. Okay, coming to answer 9. 18 is divisible by both 2 and 3. It is also divisible by 2 into 3. Matlab product of these, which is 6. Similarly, a number is divisible by 4 and 6. Can we say that number must also be divisible by 24? Can we say it? And if not, give an example to justify your answer. So we can write, no, it is not true, because 12 and 36 are both divisible by 12 and 36. These are divisible by both 4 and 6. 4 and 6, but are not divisible by 24. So if you are giving the answer as no, you have to justify that there are examples which are not divisible by like this. Okay. Answer 10. I am the smallest number having 4 different prime factors. Can you find me the smallest number having the 4 different prime factors? Now we know, because it is the smallest number. So that means we can have the product of smallest prime numbers. Therefore, it will be the product of, because when we take bigger, then we can have the bigger number from this, 4 smallest prime numbers. So the smallest prime numbers are 2 into 3 into 5 into 7, which is 210. If we take any bigger prime numbers except 7, we can take 11. It will be bigger than this. Then we cannot say that number is smallest. So this is the smallest number. Okay. Coming to exercise 3.6, which is saying find the HCF. You have to find the HCF of all of these. We can do HCF by the prime factorization method. So 18 can be written as, if I do the prime factorization of 18, it will be 2 into 3 into 3. If we do it for the 48, it will be 2 into 2 into 2 into 2 into 3. Let me do it for you for the first question. It is 293331. Then 48, it is 224, 212, 26, 23 and 31. So the HCF will be highest common factor. We will multiply the common factors 2 and 3. So it will be 2 into 3, which is 6. This is A part. For B part, it will be 30 can be written as 2 into 3 into 5. 42 can be written as 2 into 3 into 7. So HCF will be 2 into 3, which is 6. I'm removing it so that I can do more parts here. C part is 30 can be written as 2 in, okay, sorry, it is 18. 18 can be written as 2 into 3 into 3. And 60 can be written as 2 into 3, 2 into 2 into 3 into 5. So HCF will be 2 into 3, which is 6 only. D part, 27 can be written as 3 into 3 into 3. 63 can be written as 3 into 7. So HCF will be 3 into 3, which is 9. Then E part, 36 can be written as 2 into 2 into 3 into 3. And 84 can be written as 2 into 2 into 3 into 7. So HCF will be 2 into 2 into 3, which is 12. F part, 34 can be written as 2 into 17. And 102 can be written as 2 into 3 into 17. So HCF is 2 into 17, which is 34. Next part, G part is 70, 105, 70, 105, and 175. 70 can be written as 2 into 5 into 7. 105 can be written as 3 into 5 into 7. And 175 can be written as 5 into 5 into 7. So HCF is here 5 into 7, because in all three we can see 5 is common and 7 is common. So 35. We have to see in all three. H part is 91, 102, 112, sorry, and 49. 91 can be written as 7 into 13. 112 can be written as 2 into 2 into 2 into 2 into 7. And 49 can be written as 7 into 7. So HCF is, which is common in all, 7, 7, and 7. I part is 18, 54, 81. 18, 54, and 81. 18 can be written as 2 into 3 into 3. 54 can be written as 2 into 3 into 3 into 3. And 81 can be written as 3 into 3 into 3 into 3. So HCF is coming out to be 3, 3, 3, 3, 3, 3. So that means 3 into 3, which is 9. And the last part is 12, 45, and 75. 12 can be written as 2 into 2 into 3. 45 can be written as 3 into 3 into 5. And 75 can be written as 3 into 5 into 5. So HCF will be 3, 3, and 3 only. Okay, this is the first question. Coming to the second question. What is the HCF of two consecutive numbers? Two consecutive numbers, any of the two consecutive numbers, 4, 5, or let's take 9900. The HCF will always be 1. B part, two consecutive even numbers. It will be always 2. Let's take example 2 and 4. 2 is the HCF. Let's take any other 98 and 100. What will be the HCF? 2 only. Okay. Next is two consecutive odd numbers. It will always be 1. Let's take 3 and 5, 9 and 11. Okay. Coming to the third. HCF of coprime numbers 4 and 15 was found as follows by factorization. 4 is 2 into 2. 15 is 3 into 5. Since there is no common prime factors, so HCF of 4 and 15 is 0. Is the answer correct? If not, what is the correct HCF? No, the answer is not correct. The correct HCF will be 1. Okay, because when there is no common prime factor, then also we have 1 as the common factor. That means they are co-prime numbers. Okay. Coming to the exercise 3.7, which are all the word problems. The first question is, Renu purchases. Now in these types of word problems, you have to write each and every statement as well. Renu purchases 2 bags of fertilizers of weight 75 kg and 69 kg. Find the maximum value of weight which can measure the weight of fertilizer exact number of times. For this, you will find the HCF because it is maximum value. Okay. So given weight of 2 bags is equals to 75 kg and 69 kg. Maximum weight will be equals to HCF of given weights, which will be HCF of 75 and 69. For this, we will write 75 can be written as 3 into 3 into 5 into 5, and 69 can be written as 3 into 23. So HCF is 3. Okay. For answer 2, 3 boys step off together from the same spot. Their steps measure 63 centimeter, 70 centimeter, and 77 centimeter. What is the minimum distance each should cover so that all can cover distance in complete step? Now it is asking for the minimum. That means we will find the LCM. So to find the minimum distance, we'll find the LCM of given distance. LCM we can do by prime factorization. So it is 63, 70 and 77. Let's do the LCM by this ladder method only, which will be 2, 63 as it is, 35 and 77 as it is. Now it will be 3, 21, 35 and 77. Now again 3, 7, 35 and 77. Next will be 5, 7, 7, 77. Next will be 7, 1, 11. And next will be 11, 1, 1, 1. So the LCM here is 2 into 3 into 3. 2 into 3 into 3 into 5 into 7 into 11. This is the minimum distance which is 6930. So you will write at the end, hence 6930 is the minimum distance each should cover. The same line from the question itself. Each should cover so that all can cover distance in complete steps. Now answer 3. The length, breadth, the height of a room are 825, 675, 450. Find the longest tape. That means HCF of length, breadth and height. That means We will write 825. We will write 675. We will write 450. 825 can be written as 3 into 5 into 5 into 11. 675 can be written as 3 into 3 into 3 into 5 into 5. 450 can be written as 2 into 3 into 3 into 5 into 5. So HCF is coming out to be 3 into 5 into 5, which is 75 centimeter. So the longest stay required is of 75 centimeter. Answer 4. Determine the smallest 3-digit number which is exactly divisible by 6, 8 and 12. So we will first write the LCM of 6, 8 and 12. 2, 4, 6, 3, 2, 3, 2, 3, 1, 3, 3, 1, 1, 1. So LCM is equals to 2 into 2 into 2 into 3, which is coming out to be, when we multiply it, 24. Now what we have to do, we have to find the smallest 3-digit number. Okay. For this, the smallest 3-digit number is 100. Divide 100 by 24. What will it give you? We know that 24 96. 24 fours are 96. So 4 is the remainder. So the smallest 3-digit number will be 100 minus 4 plus 24, which will be 96 plus 24, which will be 120. This is what we do. Smallest number minus remainder plus LCM. Number minus remainder plus LCM. This is the formula. Okay. Coming to the next question. Determine the greatest 3-digit number exactly divisible by 8, 10 and 12. Same we will do. LCM of 8, 10 and 12. 2, 4, 5, 6, 2, 2, 5, 3, 2, 1, 5, 3, 3, 1, 5, 1, 5, 1, 1, 1. So it is coming out to be 2 into 2 into 2 into 3 into 5, which is 120. Now the greatest 3-digit number. Greatest 3-digit number is 999. Divide 999 with 120. It will give you 120 into 8. 960. Remainder is 9, 39. So do it like that only. 999. Now greatest 3-digit number you have to find. So you will just do 999 minus 39. Minus 39, which is 960. For the greatest one, you will just do the number minus remainder. And for the smallest one, you will add the LC. Okay. So 960 is the answer. Coming to the next, answer 6. The traffic lights at different road crossings. Whenever the light question comes, it is always the LCM. So it will be LCM of 48, 72 and 10. 8. 2, 24, 36, 54, 2, 12, 18, 27, 2, 6, 9, 27, 2, 3, 9, 27, 3, 1, 3, 9, 1, 1, 3, 3, 1, 1, 1. So the LCM is 2 into 2 into 2 into 2 into 3 into 3 into 3. When we multiply all these, we will get LCM as 432. So that means 3 lights will change simultaneously at 432 seconds. Or if you want to convert it into the minutes, at what time will they change simultaneously again? You have to tell the time, so that means you have to find the minutes. So it is 7 a.m. In minutes, it will be 432 seconds. How will you find it in minutes? In minutes, it will be 7 minutes, 12 seconds. 7 minutes, because 7 60s are 420. And how much is remaining after that? 12 seconds. So that means it will be 7 a.m. 7 a.m. 7 minutes, 12 seconds. Okay. Answer 7. 3 tankers contain 40 3 liters, 434 liters, 465 liters of diesel respectively. Find the maximum. That means you have to find the HCF. 403, 434 and 465. So 403 can be written as 13 into 31. 434 can be written as 2 into 7 into 31. 465 can be written as 3 into 5 into 31. So HCF is coming out to be 31. So maximum capacity of a container that can measure the diesel of 3 containers exact number of time is a container of ending statement is 31 liters will measure the capacity of all 3 containers. Okay. Next question. Question 8. Find the least number which when divided by 6, 15, 18 leave remainder 5 in each case. For this, first of all, find the LCM of 6, 15 and 18. 6, 15 and 18, it will be 2, 3 and 9, 3, 1, 3 and 5. So LCM is 2 into 3 into 3 into 5, which is 90. So required number will be, you will add the remainder, 95. Okay. Answer 9. Find the smallest 4-digit number which is divisible by 18, 24 and 32. So in this, again, LCM of 18, 24 and 32. I am writing it directly. It will be 2 into 2 into 2 into 2 into 2 into 3 into 3. which will come out to be 288. Now you have to find the smallest 4-digit number. Smallest 4-digit number is 1000. Divide 1000 by 288. It will be 3, which is 864. Give you remainder as 136. So the required number will be, as I told you, whenever you are doing the smallest one, you will subtract remainder and then add LCM in it, which will be coming out to be number as 1152. Okay. Coming to answer 10. Find the LCM of the following numbers. 9 and 4. Just do it. 292, 291, 33311. So LCM is 2 into 2 into 3 into 3, which is 36. A part. B part, 12 and 5. 2, 6, 2, 3, 3, 1 and 5. So LCM is 2 into 2 into 3 into 5, which is 60. C part, 6 and 5. 2, 3, 5, 3, 1, 5, 3, sorry, 5, 1, 1. 2 into 3 into 5, which is 30. And D part also, LCM will come out to be 60. Okay, yes. Yeah, they are saying is LCM the product of two numbers in each case? Yes, because you can see it is 9 into 4, 36, 12 into 5, 60, 6 into 5, 30, and 15 into 4, 60. Okay. Answer 11. Find LCM on each one of the factor of other. So 5 and 20. 5 fours are 2, 2. So LCM is coming out to be 5 into 2 into 2, which is 20. Similarly, B part, 6 and 18. LCM is 2 into 3 into 3, which is 80. So in this we can see we are getting the multiples as the LCM, like 18, 20, and in C part also we will get 48 as the LCM. If we see 2, 6, 24, 3, 12, 2, 3, 6, 2, 3, 3. So LCM is coming out to be 2 into 2 into 2 into 2 into 3, which is 48. And in D also, LCM will be 45. So the relation is that all the multiples of these factors are the LCM. Okay. So this is all about the exercise 3.7 and chapter 3. We have covered the chapter 3. So I hope you have understood all the solutions. Thank you.